What's going on, everybody? Cody from Motorcycle MD. Welcome back to another video. And this one we'll be diving into coils, testing them out, looking for things that can go wrong, and general practices when it comes to diagnosing maybe a bad coil or just kind of understanding exactly what it is that's going on. If you're new to the channel, welcome. My name is Cody. We do videos on motorcycle repair, maintenance, all different types of things, carburetors, you name it. If you enjoyed any of the content that you've seen here, be sure to like the video, subscribe, hit that alert button, so you get notifications when new videos come out. But if you would like to know more about your motorcycle when it comes to fluid changes, maintenance, carburetor stuff, electrical, all different types of things, I just finished this brand new free maintenance course that I want you to have. In the description there'll be a link that'll take you straight to it to sign up. Again, it's a free course, card may pop up here as well. And I think it's going to be super helpful for any of you guys out there who just love working on your own bike. So, coils, okay? I'd say probably one of the most thrown away parts many new motorcycle owners or people who are building bikes have. When it comes to diagnosing any type of ignition problem, many people just say replace the coils, replace the points, replace the spark plugs, the wires, the caps. It is a maintenance item, but again, I think that many of us out there can say that we don't really understand too much about what we're doing when it comes to knowing if you have a bad coil or not. And there are some special tools that require us to dig a little bit deeper into these things, but there are some foundational, helpful troubleshooting techniques when it comes to just, you know, seeing if this thing is good at all from face value. But before we do that, we need to know, a little bit about them. So coils come in different shapes and sizes. We have a 2-wire coil here. We have a single wire coil here for a twin cylinder, 2 coils, one coil per cylinder, and then we have for the larger motors, 4 cylinders. Usually they're powering both cylinders with 1 coil. Oftentimes referred to as like a waste spark system. And there are many different branches of information that we could dive into, and I'm not going to say that I am the most educated when it comes to the theory of electronics and magnetism and all this stuff. I know enough to get me in trouble, and I want to share that with you. So your coil is made up of 2 general windings and an iron core. Different quality of parts, different gauges, different amount of times that coil winding was spun. It all plays factors and things, but generally speaking, we have a primary system that is oftentimes powered by a key-on signal. Okay, key-on power gets sent to the primary circuit. There are many different systems that use different types of ways to do this. Sometimes they're getting sent a lot less voltage from the ECU, which then is stepped up inside of the coil, and we won't get into all of that. Regardless, basic general knowledge when it comes to coils, you have your primary winding, then you have your secondary. Your secondary is comprised of a much tighter wound or more windings, which when it comes to electronics and magnetism and that kind of thing, stuff that's going on, when those 2 systems are put close together, magnetic fields get created inside and they are stepped up in a big way. Because the whole point of that is to take a 12-volt signal or a 6-volt signal, send it through a source, which then steps it up big time, which allows that spark to jump on that spark plug. But that's not just coming 12 volts out of the battery. It has to be stepped up, and the coil is what does that. So what they do is they add in a spark plug wire, spark plug cap, which adds and steps up the resistance. In order for voltage or the path to be pushed through that type of resistance, we need amps. The higher the resistance, the more amps are required to push through that wire. But your primary coil winding will have less winding than the secondary. The secondary is the winding that's oftentimes being sent out of the coil. So there's a couple different ways to check these systems out. Generally speaking, there are some fundamental old school ways or specs, we'll say, that qualifies a coil from being good or bad. As motorcycle models progressed and their systems got more advanced, the idea of checking coils with resistance kind of went out the window when there were just better ways to check it out. Back in the 70s, there were really cool, big, bulky testers to put coils to the test, wind them up, send voltage and amperage through them, and see what kind of gap they're really jumping. And you could base the health of the coil off of those testers. But you probably don't have one, and if you did, you probably spent some money on it. So if you do have a manual for your bike and they do show a resistance reading for your coil, then you're in luck. Many of the 80s, 90s, late 2000s still suggested resistance readings on certain coils, but it never was fully a bulletproof test. Because testing a coil off the bike in one manner is great, but when you start putting that coil to the test in different temperatures, under compression, being loaded on from 3 other cylinders, there's a bunch of different things that can kind of change the outcome of how great that spark is, if that makes sense. But the very first test that is easily done is a visual inspection. oftentimes very much overlooked. We look at the coil and where it's mounted, and we look around it. We're not really sure what to look for, what it maybe should or shouldn't look like. But in most cases, electronic problems diagnosing oftentimes comes down to a very simple issue. Corroded, cracked connectors, bad connection. Every manual ever says likely due to a bad connection. That's typically what they say. But when it comes to coils, visual inspections can tell you a lot. For instance, I worked on a 79 CB750 dual overhead cam model, inline 4, and it drove me absolutely insane because I did not do a visual inspection on what I was dealing with. It would run fine one day, it wouldn't the other. Certain times with the door open, it was a little bit colder out. Sometimes it was hot in here because I had the heater on. It would just function differently whenever it wanted. I knew it was going somewhere towards the coils, but when they were mounted and looking at them, they looked fine. When this thing is mounted on the frame, you can look at it and see very clearly how it looks. I think it was mounted kind of like this, but it wasn't until I actually removed this coil was when I found this huge crack in the bottom of it. And this is very common, especially for old coils. This is the other side, and you can see that it did start to split somewhere right around here. But a crack in a coil and a device that's supposed to be sealed plays a huge problem. It can short out, weather affects it. There's so many different variables that come into play once this system has been opened and it's open to the elements. Bad, immediately bad. The cool thing about these coils is that you can change the wires and plugs on them, but if we come over to one like this, is off of old 350 or 450 or something, these are not replaceable, okay? And these wires get made into this mold. In most cases with these normally break somewhere right at the mold because the rest of it is so hard and this part is so pliable that it just usually breaks inside. So again, visual inspections are always super vital, even when it comes down to the plug cap. Many of you may or may not know this, but on these style, most caps are unscrewed. From any Honda that I've usually ever worked on, these caps will unscrew, lefty loosey, righty tighty, from the spark plug wire itself. In there is a strand, multiple strands of wire. If these cables were still in great shape, a lot of times what you can do is you can just tighten these back up onto it. You can clip a fresh section down, and you still have some more room to play when it comes to how these things route. And then you would simply just screw this back on until it stops. You're not trying to force it or rip any of the insulation out onto that screw. It's almost like a little screw head inside of there. But just tight enough. That's a great little quick way to make sure that you do have a great connection from here to here. On these ones, there's like a little point that these things will just kind of press onto in the same manner. Except that now, because of a O-ring and a little boot system inside of here, this screwing action helps push that onto that little probe that's inside the coil. So, baseline testing, some basics, okay? Normal coils are going to run between 2 to 4 ohms, maybe 5 ohms on the primary side. Okay, the primary side will be the point at which the voltage gets sent to. So even on these single coils, the point at which the voltage is sent to, which would be this black and white wire, this and this make up the primary section of that coil. So when it comes to this coil, if you have a manual and it gives you those kind of specs, it will tell you. Every bike is different, every coil is different. Maybe they want between 2.9 and 3.3. You know, it's up to the manufacturer to decide on what that number is, obviously. But we'll start here. Okay, primary side of a CB750 79 model coil. We got 2.6. Looking at the manual from a 900F, they're calling for about 3 ohms. I wouldn't consider this a bad primary. But since most coils are between that 2 to 5 ohm range, anything below or above that, if you have that type of spec, I would then start to scratch my head a little bit as to if there is a problem there. Secondary gets a little bit more complicated because now we have 3 different points of contact that we can measure. So for these ones, I don't have the caps on there right now, but the secondary side of these, we would measure spark plug wire to spark plug wire, okay, with the caps installed. But now we're diving into kilo ohms. It's almost upwards of 13 to even sometimes 27 kilo ohms of resistance going through the coil. So to test that, we would just go from spark plug wire with the cap installed We'll just act like there's a cap installed here. Right now I'm getting no reading from this, okay? So if I wanted to go further, I can take this off, pull these wires out, and this is that one that's cracked big time. Let's see if we can get a secondary resistance coming out of this. So we're going to be upwards, we're going to probably be over 13,000 ohms, 13,000 kilo ohms. This one goes up to 200K. Let's see what we're at there. And it's really important to get a really good connection on these probes. Sometimes you won't get a reading right away. And right now, I can't get a reading at all from this secondary side. Most of the time, if you're not getting any reading at all, and it's an old coil and you know it's been through some life, typically you can say that this coil would be bad because there is no secondary reading coming out of it. Let's check this other one out. So it's very erratic. 12,000, 20, 11.8 kilo ohms. I couldn't tell if I was just making a bad connection on them, if they're dirty or whatever, but that's how you would check primary, secondary. Again, on this one that wasn't cracked, the primary, we can drop this down since we're looking between 2 and 4, maybe 2 and 5. 2.6, I wouldn't consider that bad. Let's jump over to a known good coil. So this is off of a Magna, and the manual calls specifically for a 2 to 4 ohm primary. So here's our primary side, the one that gets voltage from the battery. We're at 3.1, 3.0. So this is a 3.0 coil, or a 3 ohm coil. And they're saying with the caps on and the wires all plugged in, on our secondary side, we should see between 23 to 27 kilo ohms. Okay, so we'll go to the 200K range, go right into where the spark plug goes. 25.5. We're inside spec. I'm not going to take the caps off. There's no reason for me to jeopardize a good coil, but they're saying with the cap off it should be between. So if I just went from wire to wire, which, because ultimately what you're trying to do is test to make sure that the connection between here and here, inside of here, is good. If this was stepped up to 50K or wasn't even getting a reading, I would then pull these spark plug caps off and then test the secondary again without the caps. That's what I'm trying to get at, which they're calling for between 13 to 17, which would implicate that these caps are adding about 5K ohms of resistance each. So that's primary and secondary, again, with coils that allow us, the manual allows us to do these tests on. CB350, maybe 450 coil. Again, here's our primary circuit. We can step this back down. We'll see where we're at on this one. Almost like a 5 ohm coil. Let's check this one out too. Right around the same, 4.7, 4.6. So the primary sides are good. We can try to test out this secondary with going here. Oh, this would be stepped up, that's why. I can't seem to get any reading out of this secondary side. So let me take the cap off. These are probably really bad, to be honest with you. We can take this cap off. We can check this cap out. Usually 5K. So we can drop this down to 20. Really? What about this cap? This cap bad too? No way. Oh man, that one just snapped off. I couldn't even get it off the threads. Look at that. Look at that. Just snapped the winding right off. Well, what do we got? Nothing. Out of limit. There we go. There's a reading. But not until the 2 million range. Unless these spark plug caps are supposed to be a lot higher, I doubt it. It's pretty wild. But I can go back and check inside if I can get a good connection to see if I get any reading past the... Yeah, so now I'm getting a reading on that secondary. See that? So with the cap off, I'm getting 9.4, 10K, Yeah. So I may be wrong. These may be I didn't find any spec on these in the manual from Honda. These may be a very, very high resistance plug, or they're both could be bad. Higher resistance meaning higher than what would be a normal plug wire, which would be like around 5K, like I said. Let's check this one out, see if we can get a reading now. Now that I mangled the spark plug wire. Yeah, I am. Much higher. 58? That's incredible. So much higher than the other one. Crazy. Huge difference between these two coils, and I'm not going to use them. So we can grab one of the stock. It's like these are made from Nichawa? Probably factory Honda plug caps from a single overhead cam 750. See if we can get a reading out of this plug wire. Or wire plug, actually. There we go. 4.5 ohms. So, bench testing, that's one way. Two other ways we could do kind of like an old school on the bench technique that can still be applied today in many different ways. Again, visual inspection of the actual spark itself. Now, those older testers that I was talking about earlier, they would put the coil through a test that would help to determine how much spark could jump in an air gap. The further that gap was, they would consider that to be a healthy spark or a healthy coil. I think in one manual that I read, they were looking for almost 7 millimeters of jumpage of that spark, if that's a word that I just created. Jumpage. Yeah. How far the spark jumps. Now when it comes to the spark plug coil, we're looking for a bright blue, purpley, whitish kind of spark that's being emitted all the time. When we start leaning into more of an orange or greenish color of the spark, that could sometimes indicate a weak spark. Again, this is just things that have been recognized through the years and that have been passed down to me and many other people. But we can also do a test with just seeing how far that spark does jump. Simply put, putting a spark plug into the spark plug wire, we typically want to do that when we're testing for spark, and laying it against the motor, key on, starting it through, kicking it through. We're looking for that spark to be obviously coming out of the spark plug itself. You want to be either not holding on to it, or if you are, you can grab the rubber part. If this is in any way compromised, you will feel that spark. But it shouldn't jump through this insulation into your hand as long as you're not touching anything metal. So there's your warning. Or if you want to play a trick on your significant other, just tell them to hold on to this while you turn it through. They'll love you for it. But what we can do is when we're turning it through, we can actually take the spark plug and just slowly pull it away from the cylinder head or something metal on the bike, since this is all grounded. And as we pull that away, a good healthy spark system should be able to jump even close to a quarter to a half inch of a gap off the cylinder head pretty consistently with a nice bright spark. But if you take this on here and you pull it off just barely, and all of a sudden that spark stops or becomes very, very erratic and sometimes hitting and sometimes it's not, just slightly off the cylinder head, that could be an indication of some kind of weak or intermittent issue going on. Now, is that the coil? No, it's not a silver bullet. It could be the pulse generator or whatever system is telling the coil to fire. But that's a good way to lay a foundation of your diagnosis when it comes to, okay, this is the potential to be bad. Now, if your bike has multiple coils and you say you have one cylinder that seems to be kind of erratic, switch the coils over and then double check it. Does it change? Does it stay the same? That's another way to kind of diagnose that part, because in most cases what we want is some type of known good part. If we're going to, let's say, replace the coil, put a fresh coil on there just to make sure that that's the problem. Not oftentimes you have the capability of doing that, but if you have a multi-coiled system, you can swap them over. If cylinder 1's not firing and cylinder 3 is, you can swap the coil over and see if it then changes to cylinder 3 not firing and vice versa. That being said, I will add a couple of other quick tips for you when it comes to the older systems. Because those systems were very specific when it comes to the amperage output that these bikes could produce, when it came to the coils and the starting system and the lighting system of the bikes, even in the older manuals, they would pinpoint and narrow down how many amps each bulb would take at certain RPMs and speeds and all different aspects of the bike, just to say, hey, this bike has about 4 amps left of usage for some type of an accessory or whatever you want to put on it. Newer bikes are putting out a lot more than what they should for the capability of all these aftermarket parts that people want, like speakers and heated grips, heated seats, and all this stuff. But on these older bikes, when you start swapping out these older parts, which you should, because there is great stuff out there. But I'm sure many of you have heard of like the 3 ohm coils, or compared to a 5 ohm coil. Keep in mind that resistance requires more amperage to be pushed through. Now, when you do that, you are taking from the system what it can put out to apply it to where you need it. So there can be a connection between older bikes with doing these higher end coils that it may not cause the bike to not run, but it could have a connection between a charging system issue. What people don't seem to realize is that on these older bikes, when it comes to connectors and wires and solder points and bad grounds and dirty connections, all of that stuff taxes the system. Every small or slightly bad connection takes from the system to allow it to continue to function. And with high resistance, you get temperature changes. Things tend to get hotter the higher resistance there. That's why regulator rectifiers get so hot. They're stepping down a bunch of AC voltage by use of resistors to turn out what the bike needs in that DC power. So there can be a connection between ignition and charging on these older systems when you start taking a lot from the system. In order to overcome that, yeah, sure, you can do LED lighting systems, you can clean up the connections, put new wire harnesses in. That would be very helpful, but many people don't do that. They use the factory stuff that was on there, and then now they have a problem. Just a quick tip or note, pro tip on just the overall bigger picture of your electrical system on your bike. But enough of this talking head. I'm sorry this was very me versus the camera trying to explain this type of thing, but it's very hard to show something that we can't really see, like electrical. But I hope it was helpful for you. If it was, let me know. Like the video, comment below, share it with your friend, and subscribe to the channel. And again, if you guys want a free maintenance course, it's got like over 30 or 40 videos in it. It's totally free. Link in the description. Sign up for that. Enjoy it, and I'll see you guys next time. Cody from Motorcycle MD, bringing you guys quality tips and tricks for your next build or your daily rider. Later.